Hello, in this video, let's learn how to find all the roots of x to the power of 3 equal to 27. If you're new here, don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics content. Now, if you are given this question in the easiest way, we can simply solve for x, but in this question, you are asked to find all the roots. So many will solve for x by taking the cube root of both sides. So if I take the cube root of both sides, the cube root of x to the power of 3 will be equal to the cube root of 27. Now, if I do that, you're going to find out that this is simply going to clear this, and I'm going to have my x to be equal to the cube root of 27 is just 3. So if I do that directly, I'm going to have my x to be equal to 3. X equal to 3 is a solution, but we are asked to find all the solutions, which are all the roots. Now, to find all the roots, all we simply need to do from the original expression is to bring the value of 27 to the left-hand side. So we'll have x to the power of 3 minus 27, and this will be equal to 0. Now recall that 27 can be equal to 3 to the power of 3, right? So that expression will now become s to the power of 3 minus 3 to the power of 3, and this will be equal to 0. Great. Now, in the next step, I want you to recall an algebraic expression. Now, what do we want to glean from that algebraic expression? Do you recall this algebraic expression that if you have a to the power of 3 minus b to the power of 3, this can simply be equal to a minus b, right? And that will be multiplied by a square plus the first multiplied by the second, ab, and that will be plus the second square. Great. Now, if we apply this to that expression, you'll come to see that a will simply be x, and then b will simply be equal to 3. So that expression will now give us a, which is x minus 3, right? And this will be multiplied by x squared plus a multiplied by b, that will be 3x, and this will be plus b squared, that will be 3 what? 3 squared, and all this will be equal to 0. Great. So what do we see there? We are seeing a zero product rule, and that is going to give us, if we simplify, x minus 3, right? And this will be x squared plus 3x plus 3 squared is what? 9, and all this will be equal to 0. Now, in the next step, since this is a zero product law, we're going to take the first expression out, which is x minus 3 equal to 0, and the second expression is going to give us the quadratic equation x squared plus 3x plus 9 equal to 0. Great. Now, if we simplify the first expression, if we add 3 to both sides, we'll have x minus 3 plus 3, and this will be equal to 0 plus 3. So what do we have? This will simply go for this, and then our x will be equal to 3. Now, do you notice that this is the real integer or number we got when we solve directly, right? You remember that? Great. Now, we are going to look at the other roots. And that tells us that that is a solution. Now let's look at the other roots. To find the other roots, we are going to solve this quadratic expression. I will solve it using not the factorization method, because we can't find two values that can multiply to give us 3, and when they add, they give us 9. And when multiply to give us 9, when they add, they give us 3. So what we are going to do is to use the quadratic formula. From the quadratic formula, if we compare this expression to ax squared plus bx plus c equal to 0, which is the general expression for the quadratic formula, you see that comparing that, a is equal to 1, b is equal to 3, and what do we have? C will be equal to 9. Now, using the quadratic formula, the value of our x will be equal to negative b plus or minus square root of b squared minus 4ac, and all of these will be divided by 2a. So that expression will finally give us, substituting the value of a, b, and c, x will be equal to negative 3 plus or minus the square root of 3 squared minus 4 multiplied by a is 1 multiplied by 9, and all this will be divided by 2 multiplied by 1. So the value of our x will now be equal to negative 3 plus or minus the square root of 3 squared is going to give us 9 minus 4 times 9 is going to give us 4 times 2 is 18, and that will give us 36, right? And all this will be divided by 2. So the value of our x will now be equal to negative 3 plus or minus the square root of, this is going to give us negative 27 divided by 2. So the value of our x in the next step will be equal to negative 3 plus or minus square root of 27 multiplied by the square root of negative 1, all divided by 2. So what do we have? The value of our x will now be equal to negative 3 plus or minus square root of 27 is going to give us, this is going to give us 9 multiplied by 3, right? Because 9 multiplied by 3 is 27, and this will be multiplied by j. And remember, negative 1 is j in complex what? According to complex number. So the value of our x will be equal to negative 3 plus or minus square root of 9 multiplied by the square root of 3 and multiplied by j, and all this will be divided by 2. Now gradually we are getting the solution. The value of our x will now be equal to negative 3 plus or minus 3, right, root 3 j divided by 2. So the value of our x will now be equal to, this whole thing will now give us a negative and a positive. So if we have that to be x1, this is going to be x2. That will be negative 3 plus 3 root 3j divided by 2, which is a complex root as an imaginary value, and then the value of our x3 will be equal to negative 3 minus 3 root 3 j all divided by 2. Now recall that the value of our x, which is x1, is equal to 3. So this stands as the solution to that mathematical expression given to us. So the only real root is x equal to 3. Other roots are imaginary roots. Now I want to give you a task, and the task is very easy. Take the value of x equal to 3 we got for the value of x, insert it into the original value, the original expression given to us, and see if the left hand side can be equal to the right hand side. If it does, that means the value of x equal to 3 as the only real solution is the solution to that exponential cubic expression given to us above. The other two solutions are complex roots or imaginary roots. I know you did enjoy listening or solving this math problem with us. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics content. Thanks so much for watching, and see you next time.